guys, today we're going to be going through the Trig Advanced exam, which we have done in class, and I'm going to be working through every question and showing you guys how we can solve this exam. Okay, so question 1. Find the exact value of sine 150. So the first step here would be to draw our unit circle. Okay, so we have our unit circle. And it goes A, S, T, C, all stations to central. And we're trying to find the exact value of sine 150. So you guys should know that 150 will be in the second quadrant, so over here, and it will look something like this. Okay, and we need to look at our reference angle. Our reference angle is the angle that we look at from the x-axis. Okay, so what's our reference angle? This is our reference angle. Okay, and what's the measurement of our reference angle? It's going to be 180 minus 150, which is equal to 30 degrees. So what are we actually trying to find? We're actually just trying to find sine of 30 degrees. Okay, and if you guys know your exact values, you guys should know that sine of 30 is 1 over 2, right? So your answer here is B. Okay, if you guys don't remember your exact values, what you can do is you can just put this into your calculator. So sine 30, and you get 0.5, right? And 0.5 is just 1 over 2. So you know your answer is B. Okay, next question. The triangle has sides A is equal to 8 centimeters, B is equal to 10 centimeters, and an included angle C is equal to 30. What is the area? Okay, first steps first, we need to draw out our triangle. Okay, so let's draw that out. And it says that side A is 8. So this side is 8, this side is 10, and this side must be 30. Remember, C is your angle opposite, like side C, and side C will obviously be the missing side, so this one is going to be 30 degrees. Okay, and then what can we do? We can find the area by doing C squared is equal to A squared plus B squared minus 2AB cos C. C squared is unknown. We know A squared is 8 squared. B squared is 10 squared minus 2 times 8 times 10 times cos 30. Okay, so you get 8 squared, which is 64, plus 100 minus 8 to the 16 times 10 is 160 cos 30. Okay, we can just put that into our calculator. So you get 64 plus 100 minus 160 cos 30, and you're left with 25.44. Okay, that's what C squared is equal to. Okay, so what's C going to be equal to? Well, we just square root that, so you're left with 5.043. okay, so I've done a bit of a mistake here. The question asks you to find the area. Okay, so what's the main lesson here? Yes, you need to read the question properly. Okay, so okay, let's do that again. Okay, so what do we need to find? We need to find the area. Area of a triangle is given by A is equal to half AB sine C. That's 1 over 2 times A, which is 8, times B, which is 10, times sine of 30. Okay, so 1 over 2 times 8 times 10 is just 40, times sine 30, which is 1 over 2. So your answer should just be 20 centimeters squared, which is option A. Okay, read the question properly. Okay, the question asks, what is a true bearing equivalent to the compass bearing of south 40 west? Okay, so what does this mean? So what it means is we have, oh wait, no, not a circle, we just draw compass rose. Okay, and we're looking at south 40 west. Okay, so what we need to do is we have So this is north, right? So when you want to find the true bearing, okay, since the bearing is south 40 west, it means it's 40 degrees clockwise from south, okay? So this is 40, okay? So how much would it be up to here? Yeah, that's 180. So we do 180 plus 40, which is equal to 220 degrees. So your answer is B, 220 degrees. Okay, this one, very simple. Tan is positive, cos is negative. Draw your unit circle out. A, S, T, C. Which quadrant is tan going to be positive in? In this quadrant. And let's just check if cos is negative. So yeah, cos is negative. So your answer is C, quadrant 3. Okay, in triangle ABC, A is equal to 45 degrees. Side A is 10 root 2 and B is equal to 10. Let's find the size of angle B assuming that it is acute. Okay, so we want to find angle. Okay, we're given two sides. So, let's draw the triangle out. Bell should already be ringing about which formula you need to use. Okay, so this is A, which is 45. This here, side A is that one opposite angle A, so that's 10 root 2. And then B, you can just let this one be B, that's 10, okay? So we want to find this, right? So you have two angles and two sides, so we're going to be using sine rule. So A over sine A is equal to B over sine B. So A over sine A is just, A was what, 10 root 2 over sine 45 is equal to B, which is 10 over sine B. Okay, let's rearrange it. So when we rearrange it, we get sine B is equal to 10 times sine 45 divided by 10 root 2. Okay, let's put that in our calculator. Sine B is equal to 10 times sine 45 over 10 root 2. That's 0.5. Okay, and we want to find the sine inverse of 0.5, right? So sine inverse of 0.5 is equal to B. So that's sine inverse 0.5. So you get 30, right? Just checking if it's acute. Yep. So our answer is sine 30. Okay, perfect. So next question. The angle of elevation from a point 50 meters from the base of a building to its top is 45 degrees. What is the height of the building? Okay, very standard question. So angle of elevation from a point 50 meters from the base. So let's draw a right angle triangle here. Okay, so angle of elevation is 45 degrees. The distance from the base of the building to this point is 50 meters, right? And what are we trying to find? We're trying to find what the building's height is. Okay, so we're trying to find this. Okay, so how do we find that? Well, we're given opposite and adjacent, so that's going to be tan theta. So that's tan theta is opposite over adjacent. Tan of 45 is equal to opposite, which is x, over 50. So you get 50 times tan 45 is equal to x. Okay, so put that in your calculator. 50 times tan 45, you're left with 50. Okay, so your answer is just 50 meters. Okay, using the cosine rule, find the value of c squared if a is equal to 3, b is equal to 5, and c is equal to 60. Okay, so c squared is equal to a squared plus b squared minus 2ab cos c. Okay, so c squared is what we need to find. A squared is 3 squared plus 5 squared minus 2 times 3 times 5 times cos 60. Okay, so c squared is equal to 3 squared plus 5 squared minus 2 times 3 times 5 times cos 60, and you're left with 19. Okay, and the question asks what's the value of c squared, so you don't need to root it, so your answer is just A. Okay, perfect. If a hiker travels on a true bearing of 120 degrees, what is the opposite bearing for their return trip? Okay, this one is a nice one. Okay, so the hiker travels 120 degrees. Okay, so first let's draw our compass rose. Okay, so he travels 120 degrees. So where would 120 degrees be? It's going to be in this quadrant. Okay, so this is 120. Okay, and we want to find what his return trip angle is. Okay, so what do we need to do? We need to draw a compass bearing on his start of the return, okay, which is like the end point, and we need to find what this is. Okay, so you guys should be able to see there's an alternate angle being formed, right? That's the alternate angle. I'm just gonna make that a bit thinner. Sorry. Okay. Yeah. So here is the alternate angle, right? Okay. So we know how much this is. We know how much this is. How much is this? So that's 120 minus 90, which is 30 degrees. That means we know that this much is also 30 degrees. Okay. And how much is it up? How much is this much? That much is 270 degrees. Okay. So we do 270 plus 30, which is 300 degrees. Okay. So your answer is C, 300 degrees. Perfect. Alright. This one is a very, very classic question. Teachers use this a lot because they like to mix a lot of topics, right? To trip you guys out. But it's good when you see these questions before. Okay, so first let's draw our graph. Okay, so we have our x and y axes. Always need to label them. Again, we need to draw the graph of x is equal to 2. Sorry, y is equal to x plus 2. Okay, so this is what the graph looks like. What are we concerned with? We're concerned with what is the angle of inclination. Okay, so what would the angle of inclination be? So we can kind of see that the angle of inclination is going to be this angle. Wait, this angle theta, right? How do we find the angle theta? Well, do we know what this is? Do we know what this is? Yeah, we do. That's just the change in x, and that's just the change in y, right? Which is the slope. Okay, what's the slope? The slope is 1, right? So that means for every 1 change in rise, there is also a 1 change in the run, right? So we can see that we can use your tan theta, right? Tan theta is opposite over adjacent. So that's tan theta is 1 over 1. So theta is the tan inverse of 1 over 1, and that's just 45 degrees. Okay, so your answer is B, 45 degrees. Okay, and the last multiple choice question. So this question, you guys need to remember what x and y mean on the unit circle, right? So if you guys recall, x is equal to your cos theta on the unit circle, and y is equal to your sine theta on the unit circle. Okay, so if x is equal to your cos theta, right, what's your theta? Your theta is 270, right? So x is equal to cos 270. So if you put that in your calculator, or if you know that mentally, you should know that it's just equal to 0. Okay, and y is equal to sine 270, which is just -1. Let's just confirm that. Yep, it's -1. Right, so your angle is 0, -1. and your answer is D. Okay, so next question. In a right angled triangle PQR, the hypotenuse. Okay, so very important to highlight all the main points. Okay, so the hypotenuse PR is 15 centimeters, angle P is 40, the length of the opposite side QR. So that's all we need to find, right? To 2 decimal places. Okay, so let's do that. So the hypotenuse, so it's a right angle triangle, so let me draw that out first. Okay, hypotenuse is PR, okay, and this is Q, right? So PR is 15 centimeters, angle QP is 40 degrees, okay? And we need to find the length of the opposite side QR, okay? So we're given opposite and adjacent, sorry, we're given opposite and hypotenuse, so we can use our sine theta, right? So sine theta is opposite over hypotenuse, so sine 40 is x over 15, right? So you have 15 times sine 40, which is equal to x. So my answer, value of x is times sine 40, 9.641, okay? 9.641, okay? And we need to do it to 2 decimal places, right? So my answer to x is 9.64, and we need to write down our units. Very important that we're writing down our units. Okay, so the units are centimeters, so it's going to be 9.64 centimeters. Okay. Now, in triangle ABC, the side A is equal to 12 centimeters. Angle A is 80, angle B is 40, okay? Use the sine rule to calculate the length of side B, correct it 2 decimal places. Okay, so let's draw that out. Okay, so side A, I'm going to let this side be side A, that's 12. This is 80, and this is 40, and we need to find this angle theta. Okay, let's do that. Sorry, we're not trying to find the angle theta, we're trying to find this side B. Okay, so A over sine A is equal to B over sine B. My value to A is 12 over sine 80 is equal to B over sine 40. Okay, so we do 12 over sine 80 times sine 40, which is equal to B. Okay, and we have 12 over sine 80 times sine 40. So my value to B is 7.83. Okay, and that's to 2 decimal places. And what's our units? Units are centimeters, right? So centimeters. Perfect. Okay, so next question. Sorry, 1 second, I'll just turn the fan on. Okay, next question asks, a triangle has lengths, sides A is equal to 7 centimeters, B is equal to 8 centimeters, and C is equal to 12 centimeters. Use the cosine rule to find the exact measure of the largest angle. Okay, this is a nice one. Okay, so let's draw a triangle, okay? Alright, just by looking at the sides, you guys should remember we learned this thing where the angle opposite the largest side is always the largest angle, right? So we're going to be finding angle C. Okay, so this is 7, this is 8, this is 13, and we want to find this angle theta. Okay, so I'm going to do it my way. I don't like to remember 2 formulas, I only like to remember 1 formula, and that's my base cosine formula. Right, so that's c squared is equal to a squared plus b squared minus 2ab cos c. Okay, So c squared is, what's c squared? C squared is 13 squared. Okay, 13 squared is equal to 7 squared plus 8 squared. It's 2 times 7 times 8 times cos of theta. Okay, so we're going to take everything that we have. Okay, wait, let's just solve like all our squares and stuff. So 13 squared is 169 is equal to 49 plus 64 minus 2 times 7 times 8, which is 112 times cos theta. Okay, so 169 is equal to 49 plus 64, 113 minus 112 cos theta. Okay, so we do 169 minus 113, that's 56, is equal to negative 112 cos theta. Okay, so and then we do 56 over negative 112 is equal to cos theta. So 56 over negative 112, what's that? You guys should know this off the top of your heads. That's negative 1 over 2 is equal to cos theta. Okay, now we want to move, like, we want to take the inverse, right? So you have cos inverse of negative 1 over 2 is equal to theta, right? So your value of theta is cos inverse negative 1 over 2, 120 degrees. 120 degrees. Okay, so your angle theta is equal to 120 degrees. Perfect. Alright, for this question, if you guys have seen a kite, you guys know that a kite looks something like this, right? Okay, so this side and this side are equal, this side and this side are equal. Okay, what do we want to find? Well, it says, oh wait, wrong question, wait. Yeah, it was over here. Okay, a kite has two unequal sides, 10 centimeters, so this side is 10 and this side is 20. Okay, if the angle between the two unequal sides is 70, okay, find the area of the kite, correct it to decimal places. Okay, if you can see here, something cool is going on. You can split this down the middle and you have two equal triangles, right? So you can find the area of this triangle. So I wanted to call this area 1, and then you can multiply it by 2 and you'll have the area of the full kite. Okay, so let's calculate this. So area is equal to half AB sine C, so that's 1 over 2 times A, which is 10, times B, which is 20, times sine of 70. Okay, that's 1 over 2 times 10 times 20 times sine 70, 93.97. Okay, I'm going to keep it 3 decimal places for now. 969 centimeters squared. Okay, and since you have two of those, you do 2a, which is 2 times 93.69, sorry, 969, so that's times 2, 187.94, 187.938, which you can round to 2 decimal places to be 187.94 centimeters squared. Okay, that's your answer to this. Okay, drawing this out is very, very helpful. I highly recommend you guys draw it out. Okay. Okay, next question. A triangle has area 50 centimeters squared. If two sides are 10 centimeters and 15 centimeters, find the obtuse value of the included angle to the nearest minute. Okay, first things first, what we're going to do is we're going to draw the triangle out. Okay, so let's just draw a triangle. Okay, so two of its sides are 10 and 15. Okay, and the area is 50. Okay, and we need to find this angle theta. Remember, it is a obtuse. Okay, it is an obtuse value, so it's an obtuse angle. We need to be careful of that. Okay, so our area is half AB sine C. Area was 50, 1 over 2 times A, which is 10, B, which is 15, times sine C. Okay, so that's 50 times, 1 over 2 times 10 times 15. Okay, so 15 times 10 is 150, divided by 2 is 75. So 50 is equal to 75 sine C. Okay, take the 75 over to the other side. 50 over 75 is equal to sine C. So you get 50, so you do the sine inverse, right? So sine inverse 50 over 75. So 50 over 75, and you get 41.81. Okay, remember, obtuse, right? So we have to subtract this from 180. When we do this, we get 180 minus the answer. So that's 138.189. Okay, which is equal to 100. Does it say minutes or something? Nearest minute. Okay, so that's 138 degrees and 11 minutes. Okay, perfect. All right, this question on the unit circle. Let's highlight this one. Okay, make my highlighter a bit thicker. Okay, on the unit circle, angle theta is in quadrant 2. Cos theta is equal to 3 over 5, and we need to find the exact value of tan theta. Okay, so cos theta is equal to negative 3 over 5, and it's in quadrant 2. Okay, so we need to find our value of theta. Right? What's the value of theta? Well, we have cos theta is equal to negative 3 over 5. Right? What's my value of theta? Cos. So we need to do the cos inverse, right? So theta is equal to cos inverse of negative 3 over 5. So that's cos inverse negative 3 over 5. That's 126.870 degrees. Okay, is that in, let's use the logic check. Is that in the second quadrant? Yes, it is. It's greater than 90, less than 180. So it's in the second quadrant, and we need to find the tan of that theta. So we just do tan theta. Okay, so that's tan of 126.870 degrees, right? So we do tan of answer. That is negative 1.33. Recurring. Perfect. Alright, next question. Oh, a bearings question. Okay. A lot of students tend to get tripped out on this, but you need to make sure that you know this, because these are kind of like free marks. Okay, so let's read the question. A ship sails due north, okay, for 5 kilometers, and then turns around and sails on a true bearing of 120 degrees true for 8 kilometers. Okay, what do we need to do? We need to calculate the ship's direct distance from its starting point. Okay, so let's do that. So if you guys draw this question out, it's very, very easy. Okay, let's draw its path. Okay, so let's draw a compass rose. Actually, it's my compass rose. So which direction does it go first? It goes north first. Okay, for 5 kilometers. Let's draw that out. Okay, so that's north for 5 kilometers. Okay, and then it turns and sails on a bearing of 120 degrees. Okay, so it turns and sails on a bearing of 120 degrees. So if you draw a compass rose over here, right, you will see that 120 degrees is somewhere over here, right? And how far does it travel? It travels for 8 kilometers. Okay, perfect. And what do we want to find? We want to find a direct distance from its origin point. So we actually want to find that distance over there. So let's draw the diagram a bit bigger, okay? Whoops. So it sails north, okay? Then it goes 120 degrees, okay? And we need to find this over here, right? Okay. What do we know in this diagram? Well, we know that this is 5. Oops. This is 5. We know that this is 8. And we can also find this. What is this? Well, if we look at our diagram, it's just that, right? Okay. And we know how much this angle is, right? How much is the angle? The angle is 120 degrees. So how much would this be? Well, we do 180 minus 120, which is 60 degrees. So we know that, right? And we want to find that, okay? So you guys should see here, we have side, angle, side, and we want to find the opposite side. So that's cosine rule. So that's c squared, is equal to a squared plus b squared minus 2ab cos c. Okay, what is c squared? That's what we're trying to find. What is a squared? A squared is just 5 squared plus b squared, which is 8 squared, minus 2 times 5 times 8 times cos 60. Okay, so that's x squared is equal to 5 squared 8 squared minus 2 is 5 times 8 times cos 60, 49. That's a very nice number. So we have x is equal to square root of 49. So x is equal to 7. Okay, again, units, very important. So 7 kilometers. And okay, this is something that will like elevate you from like a B to an A. Okay, if you're given a word problem, you kind of want to like reply with a word, like with a few words. Okay, so you just write something just very small. Therefore, direct distance from origin is, what is it? It's 7 kilometers. That's it. That's all you need to do. Okay, is it a hard question? I don't think it's hard. It's a fair question. Okay, this one. A cable of length 45 meters is anchored from the ground to the top of a communications mast. Okay, angle of elevation is 60. Find the exact height of the mast. Very easy. Okay, so imagine this is my communications cable, and we have a cable of length 45 meters. So this is my cable. Okay, and I'm just gonna do the ground as green because like the earth and that. Okay, so the cable of length 45 meters. Okay, so this is 45 meters and the angle of elevation is 60. What are we trying to find? We're trying to find the height of the tower. So we can do sine theta. So sine theta is equal to opposite over hypotenuse. So that's sine 60 is equal to x over 45. So 45 times sine 60 is equal to x. So we get 45 times sine 60. That's 38.97. Okay, so one thing, the question asks you to find the exact height. So technically, if you do it in decimals, it's technically incorrect, but I will accept it. Okay, just because in year 10 they're not as harsh with this stuff, but later on they'll be very harsh. Okay, so I'll show you how to do this. So sine 60. Okay, if you guys know your exact ratios, you should know that sine 60 is square root of 3 over 2. Right, so you just do 45 times square root of 3 over 2 is equal to x, right? So you can just simply write your answer as 45 root 3 over 2 meters. Okay, that's all. Or for now, I will accept the answer 45 root 3 divided by 2. I will accept 38.97 as the answer. Okay? Yeah, I'll accept that as the answer, as long as you have meters and stuff. Alright, now on to the extended response questions. Okay, so an airplane flies on a bearing of 100 kilometers on a bearing of 45 degrees true from base A to checkpoint B. It then turns around and flies 150 kilometers on a bearing of 135 degrees true to checkpoint C. Okay, show or working out to find 1. The exact distance from base A to checkpoint C, and then the bearing of checkpoint C from base A. Okay, very not a hard question. Okay. Okay, so show the compass, where is that real quick? Okay, so the plane flies on a bearing of 45 degrees true. Okay, so it flies in this direction. Okay, that's 100 kilometers and that's 45 degrees from base A to base B. Okay, and then turns and flies 150 kilometers on a bearing of 135 degrees true. Okay, so we need to draw a little compass rose thing here and figure out where 135 is. Well, we know where 135 is. It is exactly halfway of 90 and 180. Okay, and yeah, to checkpoint C. Okay, and for I, we need to find the direct distance of the base from checkpoint C. Okay, so let's show the path of this, like, what is it? It's a plane, yeah. Okay, so the path of the plane is something like this. Okay, and we need to find this. Okay, so this is almost exactly the same as the question before. I should, okay, I don't know why it's doing that. It shouldn't do that, but you guys should see that it's the exact same as the question before, right? So let's label the triangle. So if the first one is 100, and this one is 150, right? And then if we know this, then we can find this, right? But we do know this. How much is this? Okay, so how much is this? Well, if this here is 45, right, there's an alternate angle being formed, right? So this here must be 45 as well, right? So this much is 45. And how much is this much? Well, we can see that this much is 135. So we do 180 minus 135, which is again 45. So we can see that this is actually just 90 degrees, right? So there's two ways to do this. Okay, the smart way here would just be using Pythagoras theorem. Since it's a right angle triangle, you can use Pythagoras theorem, right? This is 100, this is 150, right? So if you guys remember what Pythagoras theorem is, a squared plus b squared is equal to c squared, right? What is a squared? A squared is 100 squared, b squared is 150 squared is equal to c squared. So c is equal to square root of 100 squared plus 150 squared. That's 32500. 2500. So find the square root of that. You get 180 point how many does it say? Okay, it says exact distance. Technically you'd want to leave it like this, right? But for this exam I'm gonna accept 2 decimal places, right? So this many kilometers. Okay, it's always really good practice to like do multiple ways of a single question, right? So now let's verify whether Pythagoras theorem aligns with our cosine rule, right? So let's look at that. So c squared is equal to a squared plus b squared minus 2ab cos c. A squared is 100 squared, b squared is 150 squared, minus 2 times 100 times 150 times cos of 90. So that's 100 squared plus 150 squared minus 2 times 100 times 150 times cos 90. 32500, which is c squared, right? So c is square root of 32500, right? So c is just 180.28 kilometers. Okay. Yeah, what would I do in this question? Okay, in my opinion, Pythagoras is easier, okay, because this angle is just 90 and we have to do a lot less working out. Cos rule also works, okay. If you didn't see this, then you'd have to use cos rule, but if you did see this, then Pythagoras would be the more efficient way to do it. Okay, next question. Find the true bearing of checkpoint C from base A. Okay, so now what we're trying to find in this question is, let's draw the triangle out again. This is A, this is B, this is C. Okay. Wait, I'm gonna draw this a bit better. Wait. It's like this, it's like this, and then it's like this. Yep, that's more like it. So this is A, whoops. This is A, this is B, this here is C. Okay. So airplane, so let's label what we know. 100, 150, 90. What are we trying to find? We're trying to find the bearing of checkpoint C from base A. Okay. So we're trying to find out what this is, right? This value theta. Okay. Now, pretty easy. I mean, just from the question below, we know this is 32500. So what can we do? We can just sine rule it, right? So A over sine A is equal to B over sine B. Okay. So let this be A, this is A, this is B, this is B. Okay, so that's root 32500 over sine 90, which is just 1, is equal to B, which is what is B? B is 150 over sine B. Okay, so I take the sine B over to the other side, bring the sine 90 and 1 root stuff to this side, so it's 32500 times sine 90. Okay, so my value of sine B is 150 over root 32500 times sine 90. 0.83 degrees. Okay, so what's my value of B? So we have sine inverse 0.83. Okay, 0.83. That's 56.098 dot. Okay, which is just 56.10 degrees. Does that make sense? Oh yeah, okay. Reading the question again, it says to minutes, so let's just convert this to minutes. So that's 56 degrees and 5 minutes and 55 seconds. Okay, 55 is greater than 30, so this row here will go up, so your answer is 56 degrees and 6 minutes. Perfect. Okay, on to the next one. You are given A is equal to 12 centimeters, B is equal to 16 centimeters, and angle A is equal to 40 degrees. Okay, so let's draw this triangle out. Okay, wait, sorry. Let's finish reading the question. Prove mathematically that there are two possible triangles that fit this description. Okay, and calculate the two possible values for angle B to the nearest minute. Okay, let's do that. So you have a triangle. Okay, actually, what you can do here is you can see that you have two sides and one angle, right? Which rule would you use? You'd use sine rule. A over sine A is equal to B over sine B. A is 12 over sine 40 is equal to 16 over sine B. Okay, so that's sine B is equal to 16 over 12 times sine 40. Putting that into your calculator, you get 16 over 12 times sine 40, 0.85. Right? So my value of B is going to be, shift sign answer, 58.99. Okay, I'm going to do 986 ... degrees. Okay, what you see here, this is your acute case, right? Remember, you can also have the obtuse case. How do you find the obtuse case? You do 180 minus 58.986. So that's 180 minus answer. That's 121.01 degrees. Right? So this here is your obtuse case. Okay? So there's two possible values of angle B. Okay, wait. So we need to remember that we need our answer in it's degrees and minutes, right? So I'm going to convert this to degrees and minutes real quick. So 16 over 12 times sine 40, take the sine inverse of that. Okay, and then degrees and minutes, that's 58 degrees and 59 minutes. Okay, so angle B is 58 degrees and 59 minutes, or angle B is equal to 180 minus answer, so that's 121 degrees and 1 minute. Okay, let's just verify if this can work. Okay, so if you guys remember that a triangle needs to have the angle sum of 180 degrees. Okay, so if angle B is 58 degrees 59 minutes, and angle A is equal to 40, right, degrees. What's angle C gonna be? Let's just check. So that's 58 degrees and 59 minutes plus 40, 80, so that's 81 degrees and 1 minute. Does that work? Yes, it does. It adds up to 180, so it works. Right? So that's my angle C. Okay. And then my other value of angle B is 121 degrees and 1 minute. Right? 121 degrees and 1 minute. Angle A remains 40 degrees. And angle C, what would that be? Well, I do 121 1 plus 40, and then 180 minus 1, so on. So that's 18 degrees and 59 minutes. Are they all valid triangles? Yes, they are. So, yeah, there are two possible angles that fit it. Those two possible angles are these. Okay? Alright. Okay. Next question. A ballistic missile is flying horizontally at a constant altitude of 15 kilometers. It has passed its ground target and is flying directly away from it. At a given time, the angle of depression from the missile to the target is 20 degrees. Exactly 2 minutes later, the angle of depression to the same target is 3 degrees. Okay, this is a very nice question. We've done this before. Okay, so let's draw out what this looks like, okay? So this is the path of the missile, right? And so it starts off at this point, right? This is the target, okay? So as you can see here, we form a right angle, right, where the target is here, right? So yeah, that is at point A, okay? That is at point A. That is at point A, okay? Now we look at point B, right? Because the missile just continues flying straight, and the angle of so the angle of depression here is, let's say it says 20 degrees, okay? Okay, and then okay, I mean it's still gonna work. It looks weird. The diagrams are a bit incorrect. Okay. Yeah. So this here. Okay. This here is 3 degrees. 3 degrees. Okay. So what do we need to find? Well, we need to find what is the speed of the missile in the 2 minutes. Okay, how do we find that? Well, speed is equal to distance divided by time, right? We know what the time is. Time is 2 minutes, right? Do we know what the distance is? We don't know what the distance is yet, but we can find it. The distance is just this much, okay? Well, how do we find that? Okay, so this is A, this is B, whoops, this is B, this is C, this is D, right? So can we not find AC and then BC and then subtract them to find AB, right? So let's do that. How are we gonna find AC? Okay, so we know CD is 15, okay? So we can find AC pretty easily, okay? So let's just draw a little mini triangle, okay? This is A, this is C, this is D, okay? AC is X, CD is 15, this here is 20. How do we find X? Tan theta. Tan theta is opposite over opposite over adjacent, so it's 15 over X, so X is equal to 15 divided by tan 20, so my value of X is 15 over tan 20, that is 41.21 degrees, right? Okay, and then, sorry, not degrees, it's meant to be kilometers. Okay, and then we find BC, okay? So let's draw smaller, okay, sorry, BCD, CD stays constant, BC is X, this here is 3 degrees, my angle of depression. Okay, so tan theta again, so tan theta is opposite over adjacent, so that's tan 3 is opposite, which is 15 over adjacent, which is x, right? So we do x is equal to 15 over tan 3, right? Which is 15 over tan 3. That there is 286.21 kilometers. Okay, so the reason why I said that the diagram is a little bit incorrect, because it's flying away from its target. Okay, so it's, think about it as maybe like a plane, and it's flying away from its target, and we're trying to find the speed like of the plane after it's hit its target, right? So the main idea stays the same, right? So we find AB, right? So what is AB? AB is 286.21 minus 41.21, right? So I'm just gonna do that. 41.21. That's 245. It's 245 kilometers, right? So what's the speed? The speed is 245 kilometers in 2 minutes, right? 2 minutes. What do we need to do? We need to find our answer in kilometers per hour, right? So one way to do this is to find kilometers per minute and then multiply by 60, right? So that's 245 over 2. That's 122.5 kilometers per minute, okay? And I'm going to times that by 60 to get to kilometers per hour. So times by 60, I get 7350.21 kilometers per hour, which, yeah, sounds about right for like, oh yeah, to the nearest whole number as well. So that's 7350 kilometers per hour, which sounds about right for like the speed of a plane, like a missile. Okay, alright, this question, using unit circle identities or algebraic expansion, solve the equation that, okay, pretty easy. I get 1 minus 2 sine squared theta is equal to 0.5. Okay, we're going to use algebra to solve this, right? So I take the 1 over to the other side, so I get negative 2 sine squared theta is 0.5 minus 1. Negative 2 sine squared theta is negative 0.5, right? So I get sine squared theta is negative 0.5 over negative 2, right? When you put that into our calculator, you get sine squared theta is equal to, I think it should just be 1 over 4. Yep, it is 1 over 4, right? And when we square root that, sine theta is equal to, just remember, when you square root something, there's two possibilities. It's the positive case and the negative case, because when you square a negative number, you get a positive number. So when you square root this, you get positive 1 over 2 and negative 1 over 2. Okay, so we have sine theta is equal to positive 1 over 2, or sine theta is equal to negative 1 over 2. Okay, using exact values or just putting into your calculator, you get theta is equal to 30 degrees, okay? Or, okay, so think about which quadrants sine is positive in, right? So let's draw it out, right? So which quadrant is sine positive in? It's positive in this quadrant and it's positive in this quadrant, right? So in quadrant A, so quadrant 1, my theta is 30. In quadrant B, my theta is equal to 180 minus 30, right? Because it's still positive there and we have a positive sine value, right? So that's 150 degrees, right? So we have theta is equal to 30 degrees or 150 degrees, okay? or so sine is negative. So sine is negative in the third and fourth quadrant. So how do we find our answer using our reference angle in the third quadrant? We do 180 plus 30, which is 210 degrees. Okay, that's in my third quadrant. And in my last quadrant, I do 360 minus 30, which is 330 degrees. So theta has four possibilities, right? Like sorry, 210 degrees, not negative, and 330 degrees. Okay, this one's a little bit confusing. Okay, like you probably did forget that positive and negative and this part, but like I went through it, so I'm hoping that now you guys understand. Okay, I don't think you guys will get a question like this, but it's always, you know, good to know. Okay, so on to question 23. So what we're trying to find here is a pyramid has a square base with side length of 10 meters. Okay, side length of 10 meters. The apex is directly above the center of the base at a perpendicular height of 12 meters. Show or working out to find the exact length of the slant edge. Okay, so if you guys see a pyramid, okay, so it has, the pyramid is gonna, like, the pyramid looks something like this, right? And then you have like your apex over here, something like this. Okay, so the side length is 10 meters. The apex has, okay, so the perpendicular height, so from the center point to the apex, is 12 meters. Okay, so we want to find the exact height of the slant edge. Sorry, we want to find the exact length from the slant edge, which is the distance from the corner to the apex. Okay, so let's draw the net of this pyramid. Okay, so the net of this pyramid, you have your square at the bottom. This is your apex. Okay, and this here is, okay, so if this is 10, we want to find like a triangle inside, right? So let me try to make my best representation of this, right? So it's going to be something like this. Okay, imagine this as a 3D triangle. Okay, where this here, this here is the it's like a triangle inside this pyramid. Okay, and we want to find this, right? Okay, so do we know what the backside is? We do know what the backside is. The backside is 12. Okay, do we know what this is? This over here? Well, yes, we do. That's just this, right? Which is half of 10, which is just 5. Okay, and we want to find the exact length of the slant height, so x, right? So we can use Pythagoras theorem here. So that's a squared plus b squared is equal to c squared. So that's 12 squared plus 5 squared is equal to c squared. 144 plus 25 is equal to c squared. 144 plus 25 is 169. And that's just c is equal to root 169, which is just 13, right? So that length is 13 meters. Perfect. Okay, the angle the slant edge makes with the base. So we're trying to find this theta now. Okay, so how do we find that theta? Well, you can use tan theta. So tan theta is opposite over adjacent. So that's tan of 12. Sorry, tan of theta is equal to 12 over 5. And then you just take the inverse tan of that. So tan inverse of 12 over 5, which is tan inverse 12 over 5, 60. It's 67.38. Okay, and we want to find that correct to the nearest minute. Right, so that's 67 degrees and 23 minutes. Okay, Angle between two opposite triangular faces, correct to the nearest minute. Okay, so we want to find the angle between two opposite triangular faces, correct to decimal places. Okay, so this one sounds a bit tricky, but it's honestly not. Okay, so let me draw out what they really want you to find here. Okay, so let me draw out a pyramid again. Right, so this is our pyramid. Wait, I'm gonna draw it a bit more slanted. Okay, so then you have this side. Whoops, I don't want it to snap. We have this. We have this. We have this. And at the back, there is the 0.4. Okay. At the back, there's this. Okay. What do we want to find? Okay. So it says two opposite triangular faces, right? So we want to find the angle between this face and I'm going to do the other angle in like red and this face, right? Okay, so if you notice here, what's the cross section of this pyramid? The cross section of this pyramid is something like this, right? So if we find this over here, we know the angle, okay? If this is theta, if this is theta, right, they're both going to be the same. So we can easily find what that is, right? Because we know our triangle. So our triangle is 12, 5. This is theta. So tan theta is 5 over 12. Theta is tan inverse 5 over 12. Tan inverse 5 over 12. That's 22.62 degrees. Okay? Now we're going to do 2 theta, which is 2 times 22.62, which is 45.23, but we want to do it in degrees and minutes. That's 43 degrees and 14 minutes. Perfect. Not that bad. If you draw it out, it should be pretty easy. Okay. Okay, this is the last question. Vertical flagpole stands exactly at one corner of a level rectangular courtyard. The angle of elevation to the top of the flagpole from the adjacent corner along the courtyard is, courtyard's width is 45 degrees. Angle of elevation from the adjacent corner of the other courtyard is 30 degrees. If the diagonal distance across the level courtyard is exactly 20 meters, calculate the exact height of the flagpole. Okay, so I think we've seen a question like this before. Okay, so we want to draw out our courtyard. Okay, this is the top view of our courtyard, and here is where the flagpole is. Okay, so wait, I'm going to draw this kind of 3D. I'm going to draw the courtyard in like green. Okay, that was not meant to happen. Yep. Okay, that's our courtyard. Sorry. That's our courtyard. Okay, there's a flag up here. Okay, I don't know why that turned into a okay, wait. So our flag is up here. Okay. The angle of elevation to the top of the flagpole from the adjacent corner. So from here to here, let's say, is how much? Yeah, 45 degrees. 45, okay. And the angle of elevation from the adjacent corner along the courtyard is 30 degrees. So this over here is 30 degrees. Okay. Alright, so if the diagonal distance across the level courtyard from corner to corner on the ground is exactly 20 meters, this distance over here is 20 meters. Okay, so what do we want to find? We want to find the exact height of the flagpole. Wow, nice question. So we have the length, this is the width, and this is the height of the flagpole, right? Can we write the height in terms of length? Yes, we can. Tan theta is opposite over adjacent, so that's tan of 45, which is opposite. Opposite is h over adjacent, which is L. Okay, so that's that. Okay, and then can we write the width? Sorry, let's write. Okay, so we do the L in terms of h, right? Or like the h in terms of L, or whatever we want. Right now, let's keep it like this. Okay, and then let's do the same for the width. Okay, so tan theta is opposite over adjacent. So tan of 30 is opposite, which is h, adjacent, which is w. Okay. Now we want to find the exact height of the flagpole. Okay, so there's two ways we can do this. Okay, first way, we can see that L is equal to h over tan 45, and w is equal to h over tan 30, right? And we can find the value of L and w. Okay, so the way we do this is we know that we can use Pythagoras theorem, because this here is a right angled triangle. Okay, so let me just draw that out. So this is the length, this is the width, okay, and this is 20. So we know that a squared plus b squared is equal to c squared. So that's length squared plus breadth squared is equal to, sorry, length times width squared is equal to 20 squared. Sorry, I think that will happen here. Okay, sorry. So yeah, so what's the value of the L? L is just h over tan 45 all squared plus width, which is h over tan 30 all squared, which is equal to 20 squared, which is 400. Yeah, so that's h squared over tan 45 squared plus h squared over tan 30 squared is equal to 400. Okay, what's tan 45 squared? If you guys know, tan 45 is just 1, so that's just h squared on 1 plus tan 30, square that, that's 0.33. So that's just 1 over 3, right? So that's h squared over 1 over 3 is equal to 400. Okay, so that's h squared plus, okay, so h squared over 1 over 3 is just 3h squared. Remember reciprocal and stuff. So that 3h squared is equal to 400. So 4h squared is equal to 400. Okay, so h squared is equal to 100. Okay, so the height is equal to 10. Okay, so that there gives us the height of the flagpole, which is 10 meters. Therefore, height of flagpole is 100 and it's 100, it's 10 meters. Okay. Okay, so this exam was a bit different to your normal exams. I was trying to test more of your problem solving skills than just like your memorizing skills, because I feel like the more you read the question and try to understand it and try to solve it for the answer, the better you'll be at math. Okay, so that's gonna be it for today. So yeah, if you guys have any questions, just let me know. Thank you.